Okay, so today is going to be very similar to yesterday in the fact that I'm going to give you some more formulas that you do not need to memorize. We just need to know how to apply them in a variety of situations. Okay. Yesterday we worked with those sum and difference formulas. We used those when we had addition and subtraction inside of our trig function. And we used them in situations to evaluate a trig angle or a trig function that had an angle not on the unit circle. We use them backwards. We use them to evaluate or simplify, and we use them in identities. Okay. Here we're going to work with two different kinds of formulas, and we're also going to add in solving some equations with it. Okay. All right, so I'm going to show the formulas on the next slide, write them down and label them. Once you have them written down, then I'll talk about them a little bit, okay? These are our double angle formulas because we go from W, not the letter W, but double U, to U. We go from double an angle to just single angles inside the formula. Okay, so notice how in each of the formulas we have 2u for the angle, but when we apply the formula, the angle goes to u. All right? This is helpful in a variety of situations. We're going to go through an example where we have an equation where one trig function has an angle x and one trig function has an angle 2x. Okay? When we solve our equations, we like to have the angles to be consistent. Okay? Just because these have 2u doesn't mean it has to be 2x or 2y, 2 theta, 2u, whatever it is. These can be applied even if the angle were to be like 6u. Okay? Or let's say 6x. If our angle is 6x over here, what would the angle be when we apply the formula? It would be 3x, okay? So that would still stay a 2, all right? This will always stay a 2, but our angles, whatever the angle is, gets essentially cut in half when we apply the formula, okay? So I just want you to be aware that it doesn't have to be a 2 inside. It could be any even number, and when we apply it, we just cut that angle in half. You're not going to see that very often, but I need you to know that we can still use it that way. All right, so for sine and tangent, we only have one option to apply the double angle formula, but with cosine, we have 3 different ones, mainly because of the the Pythagorean identities that we have, okay? Like I said, you're going to get all of those. You don't have to memorize them. The biggest thing is knowing when to apply them and then which cosine one to choose. Okay, so we'll go through some scenarios and talk about which one would be best. Okay, so our first will be this. All right, we're going to solve an equation. Okay. Right now we have an issue because we have a GCF of 2, but that's really not helpful. We have two trig functions that have different angles, okay? And when we solve our trig functions, or our trig equations, it's not always a big deal, but if we don't have anything to factor out there, there's really no way to solve the problem. Okay, so besides the 2 being a GCF, we don't have a trig function to factor out and separate them to set equal to 0, so we're going to need to rewrite something. Okay, do you notice how we have a double angle right there? Okay, that means we can apply the double angle formula. So the sine of, let's go back here, and this is written in your notebook. The sine of 2u is 2 sine u cosine u, which means the sine of 2x gets rewritten as 2 sine x cosine x. Okay? But that still is being multiplied to 0, added to 2 cosine x, which is all set equal to 0. So really what we have is 2 cosine x plus 4 sine x cosine x equals 0. Now we have something that we can work with. Yeah. Well, remember we're multiplying everything, right? So if we have 2 times 3 times 4, that's 2 times 12, not 6 times 12. Do you see what I mean? Yeah. Okay. So it just gets, we multiply one thing at a time, I suppose you could say. All right. Now from here, this looks a little bit more comfortable. Have a 30-second conversation with your pod. How are we going to proceed from here to solve for x? Go. Okay. Pod 2. What did you all talk about? Okay, we have a GCF of a 2, and we have a GCF of cosine of x. So if we factor that out, left over we have 1 plus 2 sine x. Okay. So it's pretty familiar now, right? Now we have 2 cosine x equals 0, and 1 plus 2 sine x equals 0. We need to know where the cosine of x equals 0. We need to know where the cosine of x equals 0. Think about it. Maverick, where does that happen?
Pi over 2 and 3 pi over 2.
Okay. Good. I'm just going to give the solutions between 0 and 2 pi. Okay, I'm not going to write out the complete solutions. Okay, over here we're looking for where the sine of x equals subtract 1 divided by 2, negative 1/2. We need to know where the sine equals negative 1/2. Where the sine is negative 1/2. Hero, where does that happen? Pi over 3, 6. Pi over 6. Okay. You got the right reference angle.
11 pi over 6.
Okay. And where's the other place?
7 pi over 6.
Good. So there would be the two places we have sine of x equal to negative 1/2. So between 0 and 2 pi, we have four angles that will satisfy this equation. Okay. I want to show you, we're not actually going to solve this problem, but I want to show you an instance where we would need to choose which cosine one to be. So in your homework, 9 cosine. This is number 9 in your homework. Okay? We have nothing that we can do with this problem. All right? We have one cosine that has 2x as an angle and one that has x for an angle. So we're going to have to change this one. All right? Now, our cosine double angle formula has three different options. Okay? Talk to your pod about which one you think would be best. Ready, set, go. Okay, so of the three double angle formulas for cosine, which one do you think is best and why? Grace, what do you think?
2 cosine squared u minus 1.
Okay, so 2 cosine squared x minus 1. And why did your pod decide that that would be helpful?
Because your column is sine.
Okay, the other two all have sines as a part of their formula, and then you would have more than one trig function in the next. Okay, now doing it this way, we have a trinomial where if we rearrange that negative 1 and minus cosine x, if we just trade places, we have a trinomial that we can solve. I'm not actually going to go through that, but I just wanted to talk about when just a case where we have to choose which cosine one to pick, okay? If the other one was a sine of x, then you may want to choose the third one listed, so everything's in terms of sine, all right? Okay, just like we did yesterday, we are going to have to work backwards a little bit, so go ahead and write this down. We're going to rewrite 4 cosine x squared minus 2. All right, so we're rewriting. Any ideas on where to start? Amber, do you have an idea?
Can you take out a 2?
All right, we can factor out a 2. Factoring never hurts. Okay, inside is 2 cosine squared x minus 1. 2 cosine squared x minus 1. Do you see that anywhere written on your paper? In your notes? Yes. Grace W., where do you see it written?
It's one of the cosine.
It's one of the cosine formulas. We have this right here. 2 cosine squared u minus 1 is cosine of 2u. So what we can do, since it follows the pattern of the double cosine angle, we can change this to cosine of 2x. And then we still have the times 2 out in front. Alright. Good stuff. Next one we're going to rewrite is this one. 4 sine of 4x cosine 4x. I want to give you some time to think about this one. So I'm going to give you about a minute to just talk to your pod about anything that you noticed compared to the formulas that you have. And just see if you can come up with any ideas. Whether you solve it or not, you can solve it or just talk about it. I don't care. We'll solve it all together. But I want you to just brainstorm a little bit with your neighbors.
Like, you can find the words and you
So the clarity here. Okay. We talk about what would happen with the angle, if it would be angle. All right, thoughts from the crowd. What are you thinking we're gonna have to apply? Which one? Okay, so we know that is it the sine of... That's over. Yes. That's okay. Fourth hour? Yeah, I can do that. Is it D or E, Holly? EO2, fourth hour. Okay. Okay. This is the formula, correct? Okay. It's a little bit similar. What does the coefficient need to be out in front? 2. No matter what, it needs to be 2. So I would write this first as 2 times 2 sine of 4x cosine of 4x. Okay. Now this right here looks like our formula. So if we're going to apply our formula, if 2 sine u cosine u changes to sine of 2u, what is 2 sine 4x cosine 4x going to change into? Chris?
Sine of 8x.
Chris said that would change into sine of 8x. How do you feel about that? Yeah? Okay. If our angle is 4x, and when we use the formula, the angle goes from u to 2u, okay? Our angle is going to double when we apply that formula. So when we rewrite it, we have 2 sine of 8x. It'll be okay with that? Okay, so those are a couple types of problems that you'll see in your homework tonight. All right. We also have another set of formulas. Okay, the power reducing formulas. All right, these are interesting. Power reducing formulas. So essentially, if you have a sine squared, cosine squared, or tangent squared that is not helpful, we can reduce the power. Like I can't do anything with sine squared. I need it to be a function with a power of 1 instead. Here is the sine squared formula. Once again, you do not need to memorize this. This will be given to you. What's nice is the cosine squared power reducing formula is very similar, only one thing's going to change. Any guesses? Someone says it's going to be sine. But actually, like, it would be more logical, but it's actually just a plus instead of a minus. So it's even easier to remember. Okay, and this all deals with, I could prove all of these to you. I don't think that's worth our time for me to prove all of these to you. If you're interested in the proof, they are in the back of your chapter. Okay, in the back, so we're in section 5 now. After section 5, there's a chapter summary, there's review exercises, there's a chapter test, and then it has all of the proofs. Not all of the proofs, but some of the proofs for these formulas. So if you're interested, you can look at those. And then our last one, tangent squared, is just crazy. But not so crazy, right? Tangent is sine squared over cosine squared. So when we take sine squared over cosine squared, all right, that's what we're going to get. So we're really just going to do one problem as an example for one of these. This will be the main type of problem that you see in your homework tonight, and it'll take us a few minutes. I'm guessing that we'll get about 10 minutes to start our homework, which will be nice, leading into tomorrow's quiz. Okay, so this will be our last example, and then we will work on some homework. So this example. Rewrite sine to the 4th x in terms of first powers of cosine. I want to rewrite sine to the 4th to where we only have functions to the first power. Okay? And that's what the power reducing formulas help us with. They help us rewrite our trig function so we have powers of 1. Okay, well, this has a power of 4. Our power reducing formulas are written in terms of what power? The second power, okay? And I'm asking us for sine to the 4th. So what are we going to have to do with sine to the 4th of x before we can even use the power reducing formulas? Sine squared x, sine squared x. Good. Okay. So now we can apply the power reducing formula to each of the sine squares. Okay, let me make sure I remember right. So we have 1 minus cosine of 2x over 2 times 1 minus cosine of 2x all over 2. What are we going to have to do with those? We cannot leave them as is. We're actually going to have to perform the multiplication. Okay, we'll start with the easiest part. 4 is our denominator. And then we have 2 binomials upstairs that we have to multiply. So when we multiply out these 2 binomials, we have 1 times 1. We have 1 times negative cosine of 2x twice. And then we have plus cosine squared of 2x. When you multiply trig functions, the angle has to stay the same. Okay, so cosine of 2x times cosine of 2x is cosine squared of still 2x. That angle has to stay the same. Are we done? No, we're not. Okay, something I'm going to do to help us out here, let's take this 4 as a denominator and let's write it as 1/4 times the quantity. That way we don't have to work with like one big fraction, okay? I'd rather multiply by 1/4 than to divide by 4 at this point, okay? So we have 1 minus 2 cosine of 2x. We have an issue, don't we? I want first powers of cosine. And here I have a cosine squared. Is that what we want in our answer? No. So we're going to have to use the power reducing formula for cosine squared. Now, since our angle is 2x, however, when we apply the cosine power reducing formula, we are going to have to write 1 minus cosine of what angle? One minus cosine, if this is cosine squared of 2x, when we apply the formula, we have 1 plus cosine of what angle? 4x. We're going to have to double it. Whenever, I'm going to come back to here, whenever we apply this formula, our angle gets doubled. So if our angle is 2x, when we apply the formula, it gives us 4x as the angle. Okay, well, we've gotten to the point where we are all in terms of cosine to the first power. Now we just need to make it look a little bit nicer. Okay, we have some division we need to perform and some combining of like terms. So the first thing I'm going to do is I'm going to say, well, when we divide by 2 here, let's just split that up into 1/2 plus 1/2 cosine of 4x. Then I see that I can take 1 and 1/2 and I can combine that, right? Those are two numbers we can add together, so we can combine that to be 3/2. And then our last step would be to go ahead and take care of this 1/4. So if we distribute that 1/4 through, we get 3/8 minus 1/2 cosine of 2x plus 1/8 cosine of 4x. And that would be the answer that we are looking for. Okay. So on tomorrow's quiz, you're going to have about 3 problems maybe from each section. Maybe that's about right. Actually, about average. You're going to have 10 questions on your quiz tomorrow. Okay? You might have 4 questions from yesterday's section. That might be it. Okay? What I need you to do is we have about 9 minutes left in class. Let's go ahead and start our homework assignment. Let's get a couple problems done before you leave. I'm going to hand back your quiz corrections. And then tomorrow we will have a chance to ask some questions. But then about 10 minutes into class, I'm going to give you your quiz. So if you have major issues, try to get to school early so I can help you. Otherwise, we'll take about 5 to 10 minutes before the quiz to go ahead and talk about questions from this homework assignment.